Hello, welcome back. In this video, we're going to go over an exercise for an application of the derivative, which is essentially finding a horizontal tangent line to the graph of this function, which is a quotient. At this moment, I want to remind you something about the horizontal tangent line. Horizontal tangent line is flat. The slope is exactly equal to 0. We're going to find f prime, and f prime is going to tell us the slope of the tangent line to the function for any x, but we're going to particularly find x's for which f prime, which is the slope, is essentially equal to 0. Once we determine the point, and we're going to write down the point slope form of the horizontal tangent line. The first thing is to find the derivative of this function by using the quotient rule. All right, the derivative of f by the quotient rule is the derivative of the top times the bottom, x squared minus 7, minus top times the derivative of the bottom, and all divided by square of the bottom. So let's find those individual derivatives here. Well, this is the sum of two functions. One of them is, or difference of two functions. One of them is x, the other one is 4. So the derivative of this is the derivative of x minus the derivative of 4, which is equal to just 1, because the derivative of x is 1 and the derivative of a constant is 0. So 1 times x squared minus 7 minus x minus 4 times the derivative of this difference here. It's going to be the difference of the derivatives of each piece. X squared comes with the derivative of 2x by using the power rule. And then 7 is a constant. The derivative of that is 0. So 2x minus 0 is essentially equal to 2x squared. Now let's simplify this expression here. Quantity squared. Okay. So now let's expand everything out. Quantity squared. As you see that the top simplifies. So this is the derivative of f. And the derivative of f tells us the slope of the tangent line to the graph of f at given point x. And remember that we're looking for a horizontal tangent line. So we want that f prime to be exactly equal to 0. In other words, we're looking for x or x's for which this quotient, which is f prime, becomes 0. All right, what we're going to do is we're going to set this quantity equal to 0 and then solve for x's and see what those x's are. But we know that the left-hand side is a quotient and the right-hand side is just a number. Why don't we make the right-hand side look like a quotient by dividing it by 1, which is going to be 0 anyway. So then we can do the cross products here, as you see. And then to get minus x squared plus 8x minus 7 equals 0. So our next task to solve this quadratic. So there are two ways to solve this quadratic. One way is to use the quadratic formula for a equals -1, b equals 8, and c equals -7. Or we can factor this polynomial directly, minus 7. So once we factor this quadratic into two pieces, and the solution is the x's that makes this one equal to 0 or this one equal to 0. Well, the first one provides you x equals 1, and the other one provides you x equals 7. So in fact, we have two roots that make the slope, which is f prime of x, 0. One of them is 1, the other one is 7. So when we graph this equation, this function, by using your calculator TI-84, you can use TI-84 for it. Then you should observe that at x equals 1 and x equals 7, there should be a horizontal tangent line. In other words, the flat tangent line. All right, the points that we got from setting f prime of x equals 0 were 1 and 7 for x entries, and if you plug x equals 1 into f, you will see that the corresponding y value is going to be 1/2. And if you substitute 7 for x in the description of f, you find the y entry of the point, which is 1/14. And as you see that, the first tangent line is y equals 1/2. Okay. And the second tangent line is y equals 1/14. And our graph verifies that. Thanks for watching. I'll see you in another video. Bye.